All right, so on this example, we're looking at a sample of 8 Toyota Camrys and their miles per gallon. We want to construct a 95% confidence interval. So the step one is we have to verify the data are obtained randomly and the sample size is small relative to the population size. So our sample size is 8, as we can see from the table. So we want to see the normal probability plot first. And so we go into stat, edit, and put all the data into list 1. It's organized in ascending order in this table that I've circled. After that's done, you want to press second y equals, click on plot 1 and turn it on. And then you want to select the last icon. We did this back in 7.3 as well, if you want to look at a video to refresh your memory about normal probability plots. And then everything else should be okay. And we press zoom 9. Okay, and then we can see the normal probability plot, and you just need to hit the trace button and then use the left and right arrow keys to go back and forth between the data points. And so the y values are the corresponding normal scores. And so I'm going to put that into the table next. All right, so I've copied the normal scores into that column. And okay, so you next want to press stat, edit, and then go into list 2 and put in those normal scores side by side with their observed values. All right, and then we can calculate the correlation coefficient, the R value. So we'll press stat, arrow over to tests, and then scroll down to linear reg t-test. Hit enter, and you shouldn't need to do anything other than scroll down to calculate. Hit enter, and then you might have to scroll down on the home screen till you see the R value, which is 0.952. Okay, and we want to compare this to the critical value on the table, the formula chart table under chapter 7. So we go there. We had a sample size of 8, so our critical value is 0.906. Okay. And so in order for us to determine if the sample's reasonably coming from a normal population, R has to be greater than the crit value, which it is. So we'll say yes. So it is reasonable that the data came from a normally distributed population. We will want to make sure there's not any extreme values either, any outliers. So we're going to go check the box plot. So we're going to press second y equals on the calculator, go back to plot 1, but now we're going to change the icon to the one I've highlighted in pink, and we'll hit enter. And then you'll press zoom 9 to see the box plot. And so since there's not any outliers shown, we'll write that there are no outliers. So because of both those criteria met, that the R value is greater than the crit value and there's no outliers on the box plot, we can use the t-distribution. We can construct a confidence interval for this sample. All right, so next thing we have to compute the sample mean and the sample standard deviation. So this is done by going to stat, arrow over to calc, and 1var stats. And we just want to run it on list 1, so that's good right there. So we'll hit enter, and we can see X bar is 27.55, and the standard deviation is 2.07. Okay, so next we want to construct the 95% confidence interval. So we could do it by hand and use this formula, or we could just use the calculator, which is the easier way. So what I've highlighted on step 4, we're just going to jump to that. So we're going to press stat, arrow over to tests, go down to t-interval, click enter. So we have two options at the top. We can either use the data from the sample, which we have, or you can use the given statistics. But we'll just use the data because we have it. It's in list 1. We already input it. And our confidence level is 95. So we'll leave it like that. If we were at 99% confidence, we'd change it to 0.99. But 0.95 is where we're at. So we're going to calculate. And then after you hit that, you will see the top in the curly braces. That's our confidence interval. So we'll represent this in parentheses. 25.82 is the lower bound, and the upper bound is 29.28. Okay, so to interpret this, we say we are 95% confident that the true population mean miles per gallon of all 2014 Toyota Camry cars is between 25.82 and 29.28 miles per gallon. What is the margin of error? Okay, so E is the margin of error. And so this would just be the distance between the point estimate, which is X bar, and either the lower bound or the upper bound. Remember, it's the same distance, either from here to here or there, the point estimate to the lower bound. So our point estimate was 27.55. So if we just take 27.55 and subtract the lower bound from it, that'll tell us the margin of error. Okay, so 1.73. And just to show it works the other way, you can do the upper bound, 29.28, minus the point estimate, and it'll be the same thing. Okay, so on this last example, we have a simple random sample of size 22, so that's lowercase n, is drawn from a population that's normally distributed, and the sample mean is found to be 43, so that's X bar, and a sample standard deviation is found to be 3. Okay, that's S. We want to construct a 96% confidence interval about mu. So in this case, we're going to use the calculator. So what I've highlighted on the screen, we're going to press those buttons. We're going to press stat, arrow over to tests, and then go down to T interval. This time, we don't have the data. We have the statistics. So we're going to arrow over to stats. And we're going to input X bar, which is 43, our sample mean. The sample standard deviation was 3, and then the sample size was 22, with a confidence level of 96%. So we hit calculate, and there it is. There is our confidence interval. 41.6, if we round it to 44.4.